Welcome to Study Loop.
Hello friends, here it is given two discs each having the mass of 5 kg and radius 100 millimeter spin as shown at the rate of 1500 rpm about a rod AB of negligible mass. Rod AB rotates about the vertical axis at the rate of 45 rpm. In the first part we have to calculate dynamic reactions at C and D. In second part, direction of spin of disk B is reversed, then how much will be dynamic reactions at C and D? Let us start doing it. Calculating angular momentum of each disk about its center of mass. Let us see here. Angular momentum of each disk about its center of mass. Ix omega x I cap I by omega y j cap. Moment of inertia of the disk half mr square. Omega x is along negative x-axis. I cap plus 1 by 4 mr square omega 2 j cap. So it can be written as, you may take 1 by 4 mr square common. So it may be written as minus twice of omega 1 I cap plus omega 2 j cap. Say this is equation 1. Now rate of change of angular momentum we have to calculate. So angular velocity of a reference frame gx by z omega, which is omega 2 j cap. So rate of change of angular momentum of each disk about its center of mass. Rate of change of angular momentum in the reference frame gx by z plus cross product of omega and hg. This value is 0 because it is rotating with constant angular velocity. Omega 2 j cap cross 1 by 4 mr square twice of omega 1 I cap plus omega 2 j cap. Now simplify it. We will write rate of change of angular momentum this would be half mr square omega 1 omega 2 k cap. This is your second equation. Now we are geometrical diagram we are drawing for calculating moment. A, B, C and D. This is dynamic reaction C. This is the dynamic reaction D. This will be rate of change of angular momentum at A. This is the rate of change of angular momentum at B. Here it will experience tangential force m omega square r. I cap m omega square I cap. Now let us see here. Since acceleration is zero, so summation of f is equal to ma is zero, which is c plus d. So reaction, dynamic reaction C and D are equal and opposite. So from here you may write dynamic reaction 2 will be equal to mr square is equal to moment of couple 2h dot g will be equal to mr square omega 1 and omega 2. The moment of couple of the reaction C into R. R is the distance between C and D. K cap to be mr square omega 1 omega 2 K cap. So C will be upon RCD, and RCD is given 0.3. Now substitute the value to find the value of C. Mass is given 5 kg, radius is given 0.1 meter, omega 1 55 it is given revolution per second, but we are using in radian per second. 1.55 radian divided by zero point 0.3. So dynamic reaction C or D will be, so in vector form it can be written as C is equal to minus 123.37 Newton I cap and D is equal to 123.37 Newton I cap. This is the answer of A part. Now for B, if direction of spin is reversed, its angular momentum also reverses. So C and D become zero. If direction of spin of B is to be reversed, then rate of change of angular momentum about G becomes zero. So C is equal to D is equal to zero. That's all for it. Thanks for watching it.